Welcome to my KCSE revision channel, Marita James. Kindly subscribe, click the notification bell, you get notified once I upload a new video. Today we are looking at Form 4 work, energy changes, and the pond energies, heat of formation. Calculate the enthalpy of formation of steam. Formation of steam, we have this question here. Hydrogen reacting with what? Oxygen, forming steam. The bond energy between hydrogen is positive 436. Oxygen is positive 497. And then oxygen to hydrogen is positive 464 kilojoules per mole. To answer this question, first of all, you need to get the bond breaking. So we have bond breaking. We have bond breaking. And the bond breaking is always an exothermic reaction. So the value it must be a negative. So the bond formation and the bond breaking, this one is involving on the reactants only. So we can have hydrogen. We have the hydrogen here, but now they are two, so we can have two here. Then plus we have the oxygen molecules. So you can see from the equation the oxygen molecule is that. So if we substitute this value, we can have 2. Then we have hydrogen to hydrogen is positive 497. Then plus there is oxygen. The oxygen is positive. So we have positive 497. So this is the bond formation. So in this case now, we can have 2 times 497. You get that? Then plus 497. 497. So sorry, the bond between hydrogen is not 497, but it is 436. So we have 2 times 436, then plus 497. And this one is giving us 13, is giving us positive 1369. So we have this is equivalent to be positive 1369, in this case kilojoules per mole. Then we have to calculate bond formation. So we have bond formation. And the bond formation in this case, delta H is equals to P, is equals to P a negative. This is an endothermic reaction. So if it is an endothermic reaction, so the value must be a negative. And this one is involving on the product. So the product we have, you can see the product we have there is the product we have a hydrogen. We have a bond between hydrogen and oxygen. So we have 2 molecules of hydrogen here. Then we have 1 molecule of oxygen. So you can have an oxygen like this. Then we have hydrogen. Then you have an hydrogen here. So the total number of bonds here, they are 2. So we have 1, 2. So the total number of bonds here, they are 2. So you can have this one here. Then we have these 2. We have these 2 there. So this one is equivalent to what? Is equivalent now to 2, which is this one, times how many bonds do we have? They are 2, so we have 1, 2. So we have times 2. This 2 is for the number of bonds, and this one is for the total number of moles. Then times now the bond between hydrogen and oxygen. Hydrogen and oxygen is 464, correct? So we have these 2. These 2, it is this one here. These 2, it is the number of bonds, 1, 2. So we have 2 times 2. Then the bond between oxygen and hydrogen is 464. So we can have this one as 2 times 2. So we have 2 times 2 times 464. And this one is giving us, so we have this one as, this one is giving us 1856, in this case kilojoules per mole. But the value must be a negative because the reaction is endothermic reaction. So this is the total energy. This is the total energy for the bond formation, and this is the total energy for the bond breaking. Therefore, to answer our question, we know that delta H, the enthalpy of formation of steam, is equals to P. We have this one as bond breaking. We have the values of the bond breaking plus the values of the bond. We have this one as the bond formation. We have this one as the bond formation. So this one is equals to P. Bond breaking, we have 1369 kilojoules per mole. Then we have plus, this one is negative, 1856, in this case kilojoule per mole. Why it is negative? It is a negative because the reaction must be endothermic. So we have 1369 minus 1856. And we have now the final value here as negative 487, in this case kilojoules per mole. Now, to get the molar enthalpy of steam, so, and that is where most of students don't do up to that part. So to do this one here, you need to get molar enthalpy of formation of steam. Very, very important to note. So we have, this is molar enthalpy of formation of steam. So molar enthalpy, remember this one is for 2 because of we have these 2 here. So we have 2 moles of this one is 2 moles of steam producing negative 487. So 1 mole is equals to what? So you get this one as positive negative 487. In this case now, you divide it by 2. So which is equivalent to what? If you divide this one by 2, so we have a molar enthalpy of that one is equals to P negative 243.5 kilojoule per mole. So sometime you will be asked what is the type of the reaction. So from the value here, the reaction is exothermic. When you get a positive, the reaction is endothermic. Follow my channel, you will get much of these calculations.